future no longer exists only in our imagination. Thanks to technology, new materials, and bold ideas, extraordinary structures are taking shape around the world. In the heart of Las Vegas, a gigantic sphere glows like an alien planet. Out at sea, millions of tons of sand and rock have been used to create a palm-shaped island that is home to tens of thousands of people. Inside a bustling airport, an entire forest surrounds a waterfall nearly as tall as a 10-story building. How were these places built, and what will life inside them be like? Let's take a closer look at some of the world's most extraordinary projects, where engineering, imagination, and ambition are constantly redefining the limits of what humanity can achieve. Falkirk Wheel, United Kingdom. The Falkirk Wheel in Scotland is the only structure in the world capable of lifting an entire boat using a massive rotating wheel. In the past, boats had to pass through as many as 11 consecutive locks to overcome the elevation difference between the two canals, a process that required significant time and effort. The Falkirk Wheel replaced that entire system with a giant wheel that rotates two water-filled caissons through half a turn, lifting an entire boat more than 79 feet in just a few minutes. Even as the entire structure rotates, the caissons automatically remain perfectly level, leaving the water almost completely still and passengers barely noticing any movement. Thanks to its perfectly balanced design, the structure requires very little energy to operate, transforming a transportation challenge that had existed for centuries into one of the boldest mechanical engineering solutions ever built. Marina Bay Sands, Singapore. Marina Bay Sands is instantly recognizable for the gigantic ship resting across the tops of its three towers, which rise nearly 656 feet into the sky. At the heart of this remarkable design is Sky Park, a complex featuring gardens, restaurants, and an infinity pool stretching about 1,115 feet, roughly the length of 3 large passenger jets lined up nose to tail. Projecting more than 216 feet into open air without a single supporting column. The enormous overhang rests above the 3 towers. The structure is designed to move with the wind and changes in temperature, yet those movements have no effect on the activities taking place above. Take a swim in its crystal-clear infinity pool just once, and with views like these, you'll feel as though you've stepped into an entirely new paradise. Palm Jumeirah, United Arab Emirates. Palm Jumeirah is home to tens of thousands of residents, while also featuring some of the most expensive hotels and villas in the Middle East. Yet just over 20 years ago, this entire area was nothing but open water. To create the island, engineers dredged more than 22,000 cubic meters of sand from the floor of the Persian Gulf before depositing it layer by layer with enough precision for the palm-shaped design to emerge exactly as planned. The sand foundation was then continuously compacted to support roads, hotels, and residential neighborhoods, while a rock breakwater stretching more than 7 miles around the island helps reduce the impact of waves and keep the newly created land stable. In just a few years, an empty stretch of sea was transformed into one of the world's most famous man-made developments. Every frond of the palm is lined with luxury mansions, marinas, and upscale resorts. If this entire piece of land once did not exist, what is it truly worth today? Hoover Dam, United States. Hoover Dam created one of the largest man-made reservoirs in the United States. It not only holds back the Colorado River, but also forms Lake Mead. It was built in Black Canyon, where the Colorado River once rushed through the gorge and frequently caused flooding. The greatest challenge was diverting the entire river through 4 tunnels carved into the mountains before construction of the main dam could begin on the dry riverbed. Once the river had been diverted, a concrete wall rising more than 722 feet gradually took shape, powerful enough to hold back the enormous reservoir while providing electricity, water, and flood control for the surrounding region. But the challenge didn't end there. If all the concrete had been poured at once, the heat generated as it cured would have caused the massive structure to crack. Instead, engineers divided the project into thousands of separate concrete blocks, embedded cooling pipes inside each one, and then joined them together to create the colossal dam that still stands today. Grand Lisboa, Macau, China. In Macau, Grand Lisboa stands out with the appearance of a giant lotus flower in full bloom. A golden sphere crowns the top, while the building widens gradually with each level. The greatest challenge was fitting hotel rooms, elevators, and complex mechanical systems into a structure defined by sweeping curves. Every space still had to function efficiently, even though the exterior looked nothing like a conventional building. To accomplish this, engineers used an intricate steel framework to create its distinctive curves. The exterior is assembled from thousands of individually shaped glass panels, allowing the building to maintain its iconic appearance from every angle. When night falls, the entire facade comes alive with an LED lighting system, making Grand Lisboa one of the city's most striking landmarks. Today, Grand Lisboa welcomes large numbers of visitors for accommodations and entertainment. The development attracts tourists, creates jobs, and contributes significantly to the region's tourism industry. Maraya Concert Hall, Saudi Arabia. Maraya has no fixed appearance. In the Ashar Valley of Alula, the sunlight determines how this remarkable structure looks from one moment to the next. More than 9,000 mirrored panels cover its exterior, reflecting the sky, towering sandstone cliffs, and the vast desert surrounding it. Behind that dazzling facade is a state-of-the-art concert hall, built to withstand scorching heat, blowing sand, and dramatic temperature swings. Every mirrored panel must align perfectly with the others. Even the slightest misalignment would distort the entire reflection. At sunrise, Maria glows with soft golden tones. By midday, the blue sky stretches across its walls. At sunset, the building takes on the deep red hues of the surrounding mountains. The structure never moves, yet the image on its surface is never the same twice. Sphere, Las Vegas, United States. No one knows what face the Sphere in Las Vegas will wear tonight. One night, it becomes the moon, hanging above the city. Next, the entire Earth appears to have descended into the Nevada desert. Moments later, all eyes are drawn to a gigantic human eye opening beneath the night sky. All of these images appear on the same spherical structure, standing more than 361 feet tall and wrapped in the world's largest LED display. Covering nearly the area of 5 football fields, it transforms the entire building into a spectacular visual performance visible from miles away. But the real surprise begins once you step inside. A massive curved screen fills nearly your entire field of view, while a beam-forming audio system makes every voice, musical note, and sound effect seem to come from the exact place your eyes are focused. At Sphere, the building itself has become the world's largest stage, where architecture and technology merge into a single, immersive performance. Tianlong Mountain Road, China. Located in the Tianlong Mountains of Shaanxi Province, Tianlong Mountain Road stretches for about 19 miles and climbs to an elevation of nearly 1,150 feet, roughly the height of a 100-story building. Dozens of tight hairpin turns wind along the mountainside before converging at a 3-level spiral bridge, the most recognizable feature of the entire route. Every change in direction adds more distance for vehicles to climb, allowing the road to gain elevation while keeping the grade within a safe limit instead of becoming an impossibly steep incline. When there was no longer enough room on the mountainside for additional switchbacks, the three-level spiral bridge extended the climb by guiding vehicles around a full loop before reconnecting with the roadway. From above, the entire route resembles sweeping lines wrapped around the mountainside, while the spiral bridge, at its highest point, makes the road look like a giant maze suspended among the rocky peaks. Jewel Changi Airport, Singapore. Located at the heart of Changi Airport, Jewel is a massive complex featuring a shopping mall, entertainment attractions, a sky train running directly through the building, and even an indoor rainforest beneath a gigantic glass dome. At the center of it all is the Rain Vortex, an indoor waterfall standing about 131 feet tall, where water plunges from the top of the dome through multiple levels below like a never-ending rainstorm. The system collects rainwater directly from the roof, regulates the flow, and continuously recirculates the water through each cycle. Surrounding the waterfall are thousands of trees sustained by an environmental control system that carefully manages light, temperature, and humidity around the clock. In one of the world's busiest airports, Jewel has transformed the time between flights into the experience of walking through a real tropical rainforest. Futuristic Aqueduct, Netherlands. At first glance, the Futuristic Aqueduct looks like an optical illusion. Boats glide across the water overhead while cars speed beneath them. Yet the two streams of traffic never cross paths. Opened in 2002, the structure carries a canal section measuring about 82 feet long, 62 feet wide, and nearly 10 feet deep across Highway N302 near Harderwijk, turning the water itself into a bridge for boats. To support thousands of cubic feet of water directly above passing vehicles, the structure uses about 777,000 cubic feet of concrete, along with steel piles and a waterproof barrier that prevents water and sediment from leaking onto the roadway below. As a result, both road and water traffic flow continuously without the need for drawbridges, crossing gates, or stopping to give way to one another. Museum of the Future, United Arab Emirates. Along Sheikh Zayed Road in Dubai, the Museum of the Future stands out with its oval-shaped form rising 253 feet into the air and a massive void carved through its center. Its most distinctive feature is the 189,000 square foot exterior, assembled from 1,024 stainless steel panels. Each panel has its own unique shape and curvature, requiring robotic-assisted manufacturing to achieve the precision needed before being delivered for installation. Between the steel panels are flowing lines of Arabic calligraphy cut directly into the facade. During the day, they serve as windows that fill the interior with natural light. After dark, light shining through the calligraphy transforms the entire building into a giant sculpture glowing above the city. As a result, the exterior is far more than a protective shell. It simultaneously serves three purposes: defining the building's shape, supporting its structure, and bringing natural daylight into the spaces within. The Interlace, Singapore. The Interlace in Singapore is a residential complex made up of 31 six-story apartment blocks stacked in multiple directions to create more than 1,000 homes. The entire development is organized as an interconnected network of overlapping buildings, forming 8 large courtyards along with numerous gardens and outdoor gathering spaces. Each block had to be precisely connected to the structural system beneath it so that loads could be transferred across multiple levels while keeping the entire complex stable. This unique arrangement allows nearly every apartment to receive abundant natural light, fresh air, and more open views than a conventional high-rise residential building. The innovative design has transformed a high-density housing development into a place where architecture and nature exist as one integrated environment. Burj Khalifa, United Arab Emirates. Rising from the heart of Dubai, Burj Khalifa stands 2,717 feet tall, reaching into an atmosphere where winds are far stronger than they are at ground level. On ordinary skyscrapers, airflow repeatedly strikes the same facade, creating powerful vortices capable of making an entire building sway. Burj Khalifa was designed in a completely different way. Its Y-shaped floor plan gradually tapers and changes as the tower rises, preventing the wind from ever encountering the same profile from the base to the summit. Just as large vortices begin to form, the building's changing shape disrupts them before they can fully develop. As a result, nearly half a mile of vertical space has been transformed into a place where people can live, work, and overlook an entire city from a height once thought impossible. Jiuquan Solar Power Base, China. The most valuable resource in the Gobi Desert is no longer hidden beneath the ground. It now stretches across the surface in the form of the Jiuquan Solar Power Base, where millions of solar panels extend to the horizon. Despite being located in a region with very few residents and little local demand for electricity, the facility generates an enormous amount of power every day. The challenge is no longer producing enough electricity, but transmitting that energy thousands of miles across the country while maintaining a stable power supply. To accomplish this, Jiuquan is connected to ultra-high voltage transmission lines that deliver electricity from the desert to distant cities and industrial centers. As a result, a landscape that was once almost completely uninhabited has become one of China's most important sources of electricity, supplying power to millions of people. Gansu Jiuquan Wind Power Base, China. Located in the Gobi Desert of northwestern China, the Gansu Jiuquan Wind Power Base is one of the largest onshore wind farms in the world. Thousands of wind turbines, standing more than 328 feet tall, stretch in endless rows toward the horizon, creating a project so vast that it can hardly be captured in a single frame. Building a facility of this scale required transporting turbine blades measuring dozens of meters in length, steel towers weighing hundreds of tons, and heavy construction equipment across one of the country's most remote landscapes before each turbine could be erected in the desert. Today, the winds that once swept across this barren land have been transformed into a massive source of clean electricity, supplying a significant portion of China's power grid. Petronas Twin Towers, Malaysia. For many years, the Petronas Twin Towers in Kuala Lumpur held the title of the tallest buildings in the world, with the two 1,483-foot towers connected by the Sky Bridge on the 41st and 42nd floors. Yet the towers never remained perfectly still. Powerful winds, hundreds of feet above the ground, cause each tower to sway continuously by small amounts. If the bridge were rigidly fixed to both towers, those movements would generate enormous stress, making the connection the most vulnerable part of the entire structure. Instead, engineers designed the Sky Bridge to slide slightly on specially engineered supports, allowing each tower to move independently while the bridge continues to provide a safe connection. Today, thousands of people cross the Sky Bridge every day, rarely realizing that the bridge beneath their feet is quietly moving with both towers to maintain that safe connection. Hong Kong-Zhuhai-Macau Bridge, China. One of the world's most complex sea crossing systems, the Hong Kong-Zhuhai-Macau Bridge stretches about 34 miles, connecting Hong Kong, Zhuhai, and Macau. But instead of crossing the entire sea on a bridge, the roadway suddenly disappears beneath the water as it approaches the Pearl River estuary, where thousands of container ships and large ocean-going vessels pass each year. Two artificial islands were built to guide traffic from the bridge down into an immersed tunnel nearly 4 miles long. Beneath the seabed, 33 massive precast concrete tunnel sections were fabricated, towed offshore, carefully lowered into place, and joined together with an alignment accurate to within just a few inches. Today, drivers can travel from Hong Kong to Macau in about 45 minutes, while directly above the submerged tunnel, giant container ships continue sailing through the Pearl River estuary as though the highway below simply doesn't exist. The Gherkin, United Kingdom. Amid London's skyline of historic rooftops and modern skyscrapers, the Gherkin stands out with its smooth, rounded form and almost no sharp edges. Rising 590 feet and completed in 2004, it quickly became one of the city's most recognizable landmarks. But its distinctive shape wasn't created simply to make an architectural statement. As the wind flows around its curved surface, the air is guided around the building instead of crashing into flat walls like it does on conventional skyscrapers. Beneath its glass exterior, a diagonal steel framework provides structural support while creating natural ventilation shafts that reduce the need for mechanical cooling. As clouds drift across the London sky, the reflective glass constantly changes with the light, making the entire building appear to move even though it never leaves its place. Chengdu SKP, China. Most shopping malls reach upward to attract attention. Chengdu SKP in China chose the opposite approach by disappearing beneath the ground. Above the surface, glass domes emerge from reflecting pools and landscaped lawns, making the site look more like a public park than a shopping destination. Few people realize that beneath this landscape lies more than 3.2 million square feet of retail space. This design preserves the entire surface for green space and pedestrians while creating demanding engineering requirements for natural lighting, ventilation, waterproofing, and emergency exits to ensure the underground environment remains bright, comfortable, and easy to navigate. From the outside, it's difficult to imagine what's hidden below. Only after passing through the glass domes does an entire underground shopping world gradually unfold beneath your feet. The Eden Project, United Kingdom. Few would imagine that an abandoned clay pit could become home to an entire rainforest. The Eden Project in the United Kingdom turned that vision into reality. Its enormous honeycomb-shaped domes enclose multiple ecosystems, ranging from tropical rainforests to Mediterranean climates. Ultralight ETFE cushions allow natural sunlight to pass through, while temperature and humidity are carefully controlled so that thousands of plant species can thrive year-round regardless of the weather outside. What was once nothing more than an exhausted quarry has become a vast green environment dedicated to research, conservation, and ecological restoration. The success of the project is measured not by the height of its buildings or the scale of its construction, but by the size of the forests it has restored and the wildlife that has returned. Huangtengxia Tianmen Skywalk, China. Would you dare step onto a glass walkway and look straight down into a canyon hundreds of feet below? That is exactly the experience offered by Huangtengxia Tianmen Skywalk in China. The attraction features a massive circular glass skywalk projecting from a cliff nearly 1,640 feet above the ground. To keep the entire structure suspended from the mountainside, a steel framework is anchored deep into the rock, supporting multi-layered glass panels strong enough to carry thousands of visitors. Surrounding the skywalk is a ring-shaped waterfall plunging hundreds of feet into the valley, creating a scene found almost nowhere else. Every step reveals the canyon directly beneath the transparent floor, turning a sightseeing experience into an unforgettable psychological challenge. Sphinx Observatory, Switzerland. The Sphinx Observatory in Switzerland places an entire research laboratory more than 11,500 feet above sea level, where most clouds drift below the surrounding peaks. Built atop Jungfraujoch, the facility operates year-round amid powerful winds, deep snow, and temperatures that frequently remain below 32 degrees Fahrenheit. Every structural component, scientific instrument, and building material had to be transported up through a railway tunnel carved inside the mountain before being assembled within the limited space surrounded by permanent ice. In return, the thinner, clearer atmosphere provides ideal conditions for observing the sun, monitoring Earth's atmosphere, and conducting scientific measurements that are difficult or impossible at lower elevations. Amid the snow-covered Alps, the observatory quietly collects data from the sky every single day. Halley 6 Research Station, Antarctica. Each year, the ice beneath Halley 6 Research Station moves hundreds of miles. That means the entire research station must be ready to move with the slowly drifting ice shelf before it reaches the sea. The facility is divided into multiple modules mounted on hydraulic legs fitted with giant skis, allowing each section to be raised above accumulating snow and relocated whenever large cracks begin forming in the Brunt ice shelf. Rather than remaining anchored to collapsing ice, the station simply moves away before danger arrives. Thanks to this design, Halley 6 continues its research into climate, the ozone layer, and Earth's atmosphere in one of the harshest environments on the planet. In a place where even the ground beneath it never stays still, the ability to move has become the very foundation of its survival. Madeira Airport, Portugal. Ocean waves crash against the shoreline below while airplanes land overhead. That's the reality every day at Madeira Airport in Portugal. Trapped between steep mountains and the Atlantic Ocean, the airport had almost no land available for expansion. Instead of reclaiming land from the sea, engineers built the extended runway on nearly 200 massive concrete columns, allowing the ocean to continue flowing beneath it. This solution added hundreds of feet of runway, while leaving the island's natural landscape largely unchanged. Constantly shifting winds and turbulence created by the surrounding mountains make every approach a serious test of a pilot's skill. The combination of a runway suspended above the ocean and constantly changing landing conditions has made Madeira one of the world's most extraordinary airports. Oppo Research and Development Center, China. Located in Hangzhou, the Oppo Research and Development Center consists of 4 high-rise towers connected by glass bridges spanning multiple levels. These bridges serve as far more than walkways. They also house offices, meeting rooms, and shared workspaces, allowing part of the building's daily activity to take place high above the ground. Creating spans of this scale required engineers to precisely calculate structural loads, wind forces, and the movement of the towers as they expand and contract with changing temperatures. As a result, the connecting bridges remain stable even as the towers themselves shift slightly under changing weather conditions. Thanks to this design, the 4 towers function as one unified workplace, reducing the need to travel down to ground level while allowing research teams to stay continuously connected. After seeing all of these remarkable places, perhaps the most astonishing thing isn't their size or the amount of money invested in building them. It's the way each one solves a completely different engineering challenge. Some were built where there wasn't a single extra foot of land. Others stand on foundations that never stop moving. Still others had to overcome powerful winds, open seas, or towering cliffs where conventional solutions simply wouldn't work. Yet through engineering and bold innovation, people have continued turning what once seemed impossible into reality. That is what truly makes these some of the world's most extraordinary and unconventional structures. Which one impressed you the most? Let us know in the comments below. If you enjoy exploring incredible places like these, don't forget to like the video and subscribe to the channel so you can join us on our next adventure. Thanks for watching, and we'll see you in the next video.